This is a presentation on data warehouses, OLAP, and data mining by Houston Griffith for the INFOST 410X class. This is assessment 4.2. So to start, I'm going to introduce what data warehouses are. Data warehouses allow organizations to collect, store, analyze, and query large amounts of data from various sources. In addition to serving as a source for many combined data sets from various sources, data warehouses also provide historical data insights over time and are therefore considered to be time variant. Data warehouses can help organizations manage vast amounts of structured data for analysis and decision making. One characteristic of data warehouses is that they are considered to be non-volatile. Non-volatility is essentially when data is entered, it is not changed or deleted. One way to update a data warehouse is using an ETL process, or extract, transform, and load. I use this on a daily basis in my job through continual adding of new data, which allows comparison to older data. Another component of a data warehouse is a fact table. A fact table stores measurable business data and connects dimension tables for context. There are several types of fact tables that exist, and most of them have similar components, such as storing metrics, dimensions, and they are able to store granular data. For example, I use fact tables daily to enable tracking user access and permissions for specific software licensing at Virginia Commonwealth University. Through this process, our fact tables are generated from our daily reports that come from our ERP, or Enterprise Resource Planning System, and they provide a running inventory of all students, faculty, and staff who are active at the university. In this daily work, I take these reports and extract, transform, and load the data to create the fact tables for tracking our student and employee access. Next, I'm going to explain what OLAP is. OLAP, or Online Analytical Processing, enables complex data analysis for decision-making using techniques like slicing, dicing, drilling down, and rolling up, and pivoting. OLAP provides a way to gain insights from analysis of large data sets, but it does not itself generate those insights. Several OLAP techniques exist, including slicing and dicing to refine data sets by filtering rows and columns. Drilling down provides detailed insights, while rolling up summarizes data. And pivoting, or rotating, refers to reconstructing the larger data set by rearranging elements to better suit the immediate analysis needs. I do this on a daily basis to try and find different insights that I might be looking for. For example, if I need to take a subset of our data set for employees, I can do that from my overall fact table of all end users at the university by filtering by their type or primary role. I can then drill down further by looking at which department they may belong to if they're an employee, or which major they're in if they're a student. And then I can roll everything up to see how many users I may have in a particular software license or group. And then I can pivot with that entire data set by only using the columns or elements of the data set that I need for my more immediate analysis. So along the lines of all the data sets that we have that we use on a daily basis, one of the major things that we do is we look to link things with a primary key referencing a specific user ID. And we have many foreign keys from a variety of different fact tables that we use. When we slice and dice and drill down and roll up and pivot, we use the data from these data sets to make an actionable decision to determine who may be new to the university to provide them access to specific software. At this point, most of the work that we do with this software is now automated. However, some pieces are still manual. So next I'm going to define data mining. Data mining discovers patterns, trends, and relationships in large data sets. Techniques like statistical analysis and machine learning enhance insights. Although OLAP techniques are incredibly useful, Used alone, they do not generate insights. They only facilitate the process of data mining by humans and/or machines. Next up, I'm going to talk about Amazon's use of data warehousing. Amazon employs AI and machine learning in warehouses for inventory optimization, demand forecasting, and worker safety enhancement. Several key innovations drive the continual optimization of their business, such as robotic process automation with literal robots, AI to optimize routes and predict product demand, and by dogfooding their own cloud infrastructure from Amazon Web Services, they can analyze all of these operations automatically in real time. In conclusion, data warehouses, OLAP, and data mining are powerful tools for business insights, aiding decision-making for resource allocation and operational efficiency. Although I am not currently using AI, machine learning, or other complex methods in my own data analysis as part of my job, it is clear that at this point, the future of this type of process will likely become highly automated through the use of AI and machine learning.